Good afternoon, everyone, and welcome to today's webinar on understanding the pandemic from the perspective of transdisciplinary teams. It is actually a webinar series across all 6 Fairview campuses. My name is Jonathan McCullough from Grade 6G and the PYP Student Council President for Fairview International School, Subang campus. I'll be your moderator and I'm excited to be hosting this session today. And also, assisting me off screen is our Assistant Primary Year Coordinator, Ms. Darlene. Allow me to start by thanking all of you, my fellow students, dear teachers, and honorable panelists for taking time in joining us in today's webinar. We will be focusing on a specific transdisciplinary theme, which is how the world works, wherein we will be inquiring into the interaction between the natural world and human societies. Our central idea is scientific advancement impacts people's lives and the environment. Before we officially start this lesson, here are a few important reminders on how you all can participate in a webinar effectively. First, listen to the discussion and presentation attentively. Second is to complete the pre-webinar activities provided prior to this session. Third is to use the chat function to message the panelists if you have experienced any issues. Fourth, use the Q&A function to ask relevant questions to the panelists. And finally, use the poll function to answer questions when it pops up to the webinar screens. As we are an IB school, our sessions will never be complete without an essential agreement. Here is 3 main webinar essential agreements that we expect everyone to follow. To further enlighten us with today's issue, as they share their perspectives and expertise on this topic, let me introduce our honorable panelists, Ms. Lee Hsien Chu and Dr. Renard Siu. By this time, I'm pretty sure that all of you are familiar with the term pandemic. For the benefit of those who are not familiar, pandemic is a disease that spreads to the whole wide world. This is a type of pandemic similar to SARS and Ebola virus that we faced before. Truly, pandemics have affected our society in many forms. This pandemic shows us how urgent and the need is and how unprepared we are as a human race to live sustainably. We must accelerate our pursuit of sustainable technologies to ensure the survival of all the species on this earth. To enlighten us more about this issue, I'll leave it here until further discussion by our panelists. Now let me pass our floor to the first panelist, Ms. Lee Hsien Chu. She is a freelance writer and a full-time mom to twins. She has previously written articles for mainstream publications like The SAR, New Straits Times, as well as The Edge Options, Pull Out, and Of the Edge magazine. Apart from her writing prowess, she is also currently the co-facilitator of the Arts Discovery Tours for Kids and coordinator of children's programs at the Ilham Gallery KL. Ladies and gentlemen, let's all welcome Ms. Lee Hsien Chu with a topic on biomimicry, design and innovation inspired by nature. Considerations for the current pandemic.
Thanks, Jonathan. Hi, everyone. I'm Lee Hsien. And as Jonathan said, I work in a gallery. I'm not a scientist, but I want to show you that design has a lot of impact on science and also innovation. And there are a lot of intersections between art and science. So it's not two separate topics. And I hope that you can see that at the end of this presentation. So before we start, let's have a look at this slide. Can you see all the items in this slide? What do you think, what do these things have in common? If you have answered biomimicry, obviously because that's what the topic of my presentation is about, can you tell me what sort of, what aspect of biomimicry is present in each of these things? Okay, if maybe you can try to put that down in your chat function. I'd like to see some of your answers. So we can see, you know, I'll just, while you're putting in your responses, these are all things that we have had experience in our daily lives. We have all worn shoes. You all wear shoes like that to school. You've listened to music on an MP3 player that looks like that. And I'm sure you've taken a holiday and gone on an airplane, or you've actually received some vaccinations through injections at the doctors. And our homes have also painted walls like the picture you see there. And some homes also use, in Malaysia, they also use solar cells to power the water heaters at home. So what are the, like the shoe, you know, what part of the shoe is actually inspired by nature? What part of the MP3 player? What about the airplane? What about the paint? Yeah, airplane is similar to a bird. Yes, that's right. Yes, they're all designed by taking, I'm not sure about the paint. Yeah, something interesting about the paint coming up. What do you think? You know, what about the injection? What part of the injection is inspired? The plane is a very obvious one. Everybody is answering the plane. Good job. What else? Mud? Yeah, some people say mud, natural sources. Yeah, maybe they use natural sources. His shoe is inspired by the skull, someone said. Yeah, injection by mosquitoes. Good, very good guess. Rubber. Yeah, those are actually materials, but really we are looking at functions in nature, not so much the materials. Biomimicry looks at the functions of nature that we can replicate. Okay, I'm going to move on and sort of give you some answers. All right, good, great responses. Yes, someone said the shoe is Velcro. Okay, next slide. Okay, biomimicry, it looks like a big word, but it's actually from the Greek words bios, which means life, and mimesis, which means imitation. Mimicry just means mimicking, right? To copy something. So next slide, you can see that I'm going to take you through one by one. Okay, the shoe, someone guessed Velcro, that's right. So Velcro is found on many shoes that we have. Right, and also we use them in clothes and in other items and bags, and we may not have thought about how Velcro came to be invented. So actually, it's actually by a man called Georges de Mestral, and he was hunting in the Swiss Alps, the mountain, and with his dog, when he noticed that these birds, these plants that you see in the slide, kind of stuck to his clothes and stuck onto his dog's fur. And then when he studied it, he realized that the plant, the surface of the plant, if you can look closely, there's a lot of tiny hooks. So he noticed that these tiny hooks actually hook onto things. And that's why he was inspired by the features of this plant to create Velcro. You're right, Velcro, for those who answered Velcro. Okay, next slide. In the next slide, you can see a butterfly and an MP3 player. And actually, a lot of us use these gadgets like the one we see here. And the display screen, a lot of us, the gadgets have a lot of display screens, right? Butterfly. So what happened was a technology company called Qualcomm. Qualcomm is a big technology company. It observed the unique properties of the butterfly's wings. And you know, the wings actually, they were inspired to use the technology in nature of the wings to improve the manufacturing of their display screens. Because these structures, the wings, actually reflect light depending on the wavelength. And they applied the same principle to create brighter screen displays for their electronic devices that are more readable and even consume less power. Isn't that amazing? Okay, now, not everybody was not sure about the lotus plant and paint. Okay, so it's actually the lotus plant is related to dust and dirt repelling paint. We've seen a lot of beautiful lotus flowers and the leaves. They always look so fresh and vibrant, isn't it? When they are sitting even on a muddy pond or a lake, how come in the muddy area they still look so clean and nice? Well, actually, the lotus flower and the leaves, if you look very closely at it, it's got micro rough surfaces that naturally repel dust and dirt particles. So when water washes through them, they sort of wash over the thing, and then the dirt and particles, they kind of disappear, and they leave the petals and the surfaces sparkling clean. So they always look clean. A German company called ISPO actually spent 4 years researching this phenomenon, and it has actually developed a paint with similar properties. So these micro rough surfaces of the paint, the surface of the paint, actually pushes away dust and dirt. So if you use this paint outside your house, you don't really have to wash the outside of your house, right? I think everybody wants this kind of paint, right? And maybe we hope that our bodies are like that as well. Okay, mosquito bites. Okay, someone said mosquito bites and the injection needles, right? Well, I don't know about you, but I don't really like getting an injection. And the good news is that a Japanese scientist from Kansai University in Osaka in Japan has studied the mosquito and used what he learned from it to create a less painful injection needle. You see, the problem with our traditional injection needles is they're smooth. And the smooth area means there's more surface area that comes in contact with your nerves. So when the needle goes in, it touches a lot of nerves, it has a lot of surface area, and that's where your pain comes from. So if you actually study the mosquito, you notice that the point where the mosquito bites you, the proboscis, actually it has serrated. It's serrated. Actually, it's like a cake knife. It's serrated, or a butter knife. So there are fewer points that the nerves of the skin touch the needle. So that's why this kind of technology can be used to make less painful injection needles. I'm not sure whether they're using it in Malaysia yet. Okay, next slide. And the very obvious one is the leaf and solar cells. So electrons in a leaf cell can actually convert sunlight to fuel in trillions of a second. So it's very fast and very efficient. So scientists, of course, were inspired by this to create solar cells that are used to generate energy that can be used for electricity or to even heat water in our homes. And the next slide is the very obvious example of the aeroplane that is inspired by the flight of birds. And of course, everyone knows that Leonardo da Vinci first studied birds to create his flying machine that he has drawn a lot of pictures on. And much later, the Wright brothers studied the drag on the wings of turkey vultures, or buzzards as they call them, to invent the precursor to the first commercial aeroplane that we know now today. So all these are examples, some quick examples of biomimicry that we see in our daily lives.
Let me cut you for a while on this part, Ms. Li Xian, as we have a poll posted for our viewers which asked them, do you agree that most innovations were inspired by nature? While the audience is responding, I will talk a little about what you just shared earlier. I didn't know that lotus plants were actually made to create dust and dirt repelling paint. Like, you don't have to clean your walls anymore.
Yeah.
Thank you for your responses. You will see the result now. Oh, wow. A whole lot of you. It's actually very obvious that all of you say that, yeah, a lot of things are inspired by nature. With this in mind, it only shows that we can utilize our natural resources to fight against pandemics. Miss Li Xian, do you know innovative products created and inspired by nature?
Yeah, I know. I'm going to share with you a few more case studies. And you know, even Steve Jobs, you know, he also agrees that the new innovations of the 21st century will be actually the intersection of biology and technology. Okay, if you look at the next one, next slide. Yes, so we can look at, if we are thinking about biomimicry as a new science, we can look to nature in three ways. We can look at nature as a model. So biomimicry is a new science that studies nature's models and systems and then imitates or takes inspiration from these designs and processes to solve all of human problems. For example, like a solar cell inspired by a leaf, you know, and later on I'll go through more detailed examples. And nature, we need to look at nature as a measure because biomimicry uses an ecological standard to judge the rightness of our innovations. So, you know, the world has been around for 3.8 billion years, right? We have evolved. We have a lot of evolution, and nature has learned over that long period of time what works, what is appropriate, and what lasts. So the things that are not appropriate have not lasted at all. They are no longer, they are extinct. And nature as a mentor. So biomimicry is a new way of viewing and valuing nature. And it introduces an era based on not what we can extract and take from nature. You know, we don't look at the tree as something we can use to make other things that we want, only humans want, but on what we can learn from it. Okay, I will show you more examples of this as we move on. Next slide. Okay, let's look at this. Let's look at the Kingfisher and the Shinkansen, the Japanese bullet train. I'm not sure whether any of you have been to Japan. Well, if you have, maybe you've been on the bullet train, the Shinkansen. And I went last year with my kids. And, you know, we took a bullet train from Osaka to Kyoto that normally takes 45 minutes or more. But in the bullet train, you only take 15 minutes. So it really cuts the journey by a lot. And it's a marvel of modern technology. In the beginning, if you can look at the picture on the far right, it had a rounded nose. So actually, when it had a rounded nose, each time the bullet train comes out from a tunnel, it will have a thunderous, loud noise. Because there was a change in air pressure, it was going so fast, they will cause a thunder sound, and then it will cause a lot of noise pollution in the area it was in. So the train's chief engineer just happened to be a very avid bird watcher. And he used to watch the kingfisher, how the kingfisher would dive with his very long aerodynamic beak into the water very quietly and pick up fish without anybody even realizing it. So he used the kingfisher as a reference, and they created a sharper nose for the train. So the change in the nose of the train resulted in a quieter train that also consumed 15% less electricity and goes 10% faster than before. So you can have a look at the video in the slides later when Mr. Evan has sent it to you. Okay, next slide. Let's now look at termites. You know, termites, everybody is afraid of termites because they come and eat things in your house if they are made of wood. But the interesting thing about here is that in Harare, in Zimbabwe, you know, they built this place called Eastgate Center, which is the largest office and shopping complex. And it's an architectural marvel. So the building owners, you know, it's such a big building. So they thought, oh my goodness, the aircon bills are going to be really high. So they didn't want to incur such high bills. So they challenged the architect to build a building that that could cut down on electricity and air conditioning bills. So in nature, so the architect studied, Mike Pierce, he studied nature and how termites would build skyscraper-like big mounds, you know, that were ventilated by a complex system of tunnels. So by studying the ingenuity of termites, he was able to design a building with a natural cooling system that harnessed the features of nature. There's also a video on National Geographic you can watch on this case. The next slide. Okay, and all of us have used some level of glue before in school. So, and you know, they're called adhesives, right? So now there are a lot of nano adhesives, which are very, you know, glue that really makes it stick very hard to a surface. So what happened was scientists actually looked to make another kind, a better kind of super glue. And they studied, you know, the geckos, geckos are like in the same family of like the house lizard. And, you know, they're very good at sticking to walls and glass, but also very good at unsticking themselves on the dry surface. But in a wet surface, this kind of stickiness is not so good. So you see, sometimes they get stuck in the wet sink at home, right? And you can't get them out. So they also looked at mussels. You know, mussels, they are also very good at sticking to things in the ocean. So the mussels uses its byssus traits to stick to the ocean. So they studied two of these things and they came up with a glue that combines the best of dry adhesion of the gecko feet with the wet adhesion of the mussel threads. So it's very interesting how they combine two types of nature things into one super thing that they created. Okay, and the last big example I want to talk about is shark skin. You know, there's a lot of people who think, wow, sharks are like amazing creatures. And you know, the shark, I want to tell you one more amazing thing about the shark. The shark skin, actually, it consists of a lot of tiny little, it's actually the surface of is millions of microscopic diamond-like structures. And because the shark skin is not smooth, you know, it's all these diamond-like structures like the picture. And because of that, the bacteria cannot sort of grow on that surface. It cannot colonize that surface. It cannot create a kind of biofilm that will harm the shark and make the shark sick. So they studied the skin and they managed to come up with a kind of synthetic surface based on this feature. And they created a surface, a film, that you can use in like hospitals, in public toilets, in childcare facilities, in commercial venues, and in laboratories and animal research facilities to protect you from getting touching bacteria, these antibacterial surfaces. So amazing, right? And this is like one kind of thing we could probably use in a pandemic which involves bacteria, right? Okay. So next slide. Now, a lot of you ask me questions. I think a lot of questions on how can biomimicry help in the current pandemic? How can we use it to survive in the current pandemic? What can we learn from biomimicry for the current pandemic? Well, currently, you know, let's observe first. Let's think about what we observe from the current pandemic. These are things we know, right? Currently, there's no cure or vaccine. It is a novel and new virus. We know very little about it. So there's a lot of urgent and collaborative medical research. It spreads by human contact. That's why we all have to stay home. Even if we go out, we have to stand, you know, we have to have social distancing. Virus survives on surfaces, you know, different surfaces for different amounts of time. And then the only way we can keep ourselves clean is using soap and water and sanitizer with alcohol content of 60%. You'll break down the virus. And then we also know that there are a lot of people working in the hospital, like doctors and nurses and all of these medical professionals. They're called our frontliners. How are we going to protect them, even as they protect us? And now we are ordering a lot of food in. That's also packaged in plastic because we want it to be sanitary, clean. And then, but a lot of plastic packaging leads to plastic waste issues. Last time we tried to get rid of plastic, but now the plastic is coming back again. And then food supply issues, you know, in the long term, the borders are closed. So how are we going to make sure we get enough food for ourselves? So, you know, I'm sure you can think of many other things. You know, what other things have you observed? So if you look at the next slide, So these are things that I could see. I might personally can see that it's maybe what we need. And I got some of them from an article too that's linked to this slide. Then nature actually has many possible solutions to future pandemics and existing viruses like the one we face now, the COVID-19. So we must honor what other species have to teach us. So that's why it's important to have animal conservation, nature conservation, because if we don't have diversity of species, we'll not be able to learn from them. And then if they all die off and become extinct, we will lose our potential to find the cures or treatment for any viruses that or pandemics that we see. So for example, like bats, you know, a lot of people say, okay, this thing came from the bats. But you know what? The bats are not dying off from it. It's surviving in the bat. The bat is a carrier, but it's still surviving. So maybe we need to study bats, you know, what kind of things are in the bat's body that sort of helps them survive this kind of viruses, even though they are carrying them, right? And also, we see that a lot of our frontliners, they need a lot of personal protection equipment, PPE. So we actually, and a lot of time, the factory cannot manufacture them fast enough. A lot of them are made of plastics and polymers. So we need better materials to actually create PPE. You know, we can think about what kind of natural materials we can use, and we need also faster, cheaper, easier, and more efficient ways to manufacture them. And we also need more biodegradable alternatives to plastic. We have some, but maybe we need more, especially for food packaging. And the next slide also, we can see we need virus-resistant surfaces. Just now I talked about bacteria-resistant surfaces. Now maybe we need a virus-resistant surface covering that could degrade them when people touch it, then the virus will break down. And we also need a lot of sustainable cleaning and personal care products, you know, that we can use a lotion, maybe that can, our cleanser or our cleaner or the things that we put to moisturize our hands can already be anti-virus. And then we can also need some cleaning agents that are very effective so that we can reuse some of the personal protection equipment. We don't have to use and throw, which is currently what is happening. So what other things do you think we need now? You know, how we think about it, you know, after this webinar, how can we draw inspiration from nature for solutions? I will go through a process that you can go through to think of some of these design solutions. So we need short-term solutions now, quickly, but these solutions will have long-term benefits. So while we are all focused now on COVID-19, if we think of a good solution, a lot of the solutions can be used for a long time, and then we will be better prepared when we have another pandemic in the future. It cannot be helped. We might probably experience another one in our lifetime. We don't know. Okay, so the next slide.
Okay, I'll just like come in here for a while. I think what I can see here is that there are things in nature that we can use in this pandemic. For example, the shark skin, which deters the colonization of certain diseases causing microbes. Using this concept, we can make surfaces that prevent a particular bacteria or spread of virus.
Yeah, good idea.
Yeah, just continue.
Okay, I'm going to continue. So what we need to do is to take your seat in front of nature's classroom. This is the main thing that, you know, instead of sitting in the classroom, the nature is outside. We should go outside and look for some interesting ideas. Okay, so how can we do that? The next slide. We need to change the way we think about learning. We need to have what you call a paradigm shift. Okay, paradigm shift means you change the way your mind thinks about something. So for example, we need to change from learning. Now we currently mostly applying a lot of traditional learning when we learn about nature, right? About biology. When we tend to learn about it, we are not learning from it. Okay, the two words about and from, very important distinctions. So for example, when we're learning about a tree, like the oak, we are learning about the name of the tree, the leaves, what are the features of the leaves. We learn about the range of the tree, where it can exist and survive. And then we think about all the uses of the tree. We can use it to make furniture, veneer, which is like flooring, and with a lot of sort of coatings. So we think about how we're going to use the tree. This is a kind of passive learning, you know, but we are all IB learners, right? So as an IB learner, we need to have active and applied learning, the IB style of learning. When students learn to see the technology in nature, when all of you learn to see that nature has its own technology, it's not the technology that we use in computers or gadgets, but it's its own kind of complex and very elegant kind of technology, we can open our eyes to see that a lot of the things, innovation already exists, is embodied in plants, animals, and other organisms. So for example, if we are learning from the tree, we can learn that the tree is like a canopy, you know, it's like a cover. It humidifies air, increasing the inland precipitation, so it provides its own moisture. And then leaves capture solar energy, you know, like what we said, the solar cells, and it's non-toxic and biodegradable, the leaves. And the limbs also create structural support with minimal material. You know, the limbs are like bones. They create a way for everything else to hang, but very little structure actually. And the trunk moves water, the trunk of the tree moves water against gravity without motorized pumps. We use pumps all the time, but we don't, the tree doesn't need to have a pump, right? So we need to be IB learners, and we need to be active and thinking about what we can learn from nature and how we can apply it to problems that we have. Okay, now the next slide, I will talk about Janine Benyus is actually a big authority on biomimicry. She wrote this book on biomimicry, and it was published in actually 1997, and she's a big authority on it. And she says that there are 9 basic principles of biomimicry that we should follow actually. We try to follow when we look at inventions. For example, nature runs on sunlight. Nature uses only the energy it needs. Nature fits form to function. It doesn't think about form first. It doesn't think about how a thing looks first. It sort of thinks about what the thing can do, and then the form will suit the function. And nature recycles everything. Nature rewards cooperation, you know, like bees and ants. Nature banks on diversity. Nature demands local expertise. Nature curbs excesses from within, and nature taps on the powers of limits. So, you know, for human beings, we always try to push limits, but everything else in nature is very creative within its limits. So we need to actually apply these basic principles when we are designing something. And you know, a lot of us want to live like zero waste lifestyle, recycle everything, reuse everything, try to consume less now. So it's actually a very perfect model for us to think about solutions. Okay, if you look at the next slide. The next slide is on the life's principles. So it's similar to just now the 9 points I mentioned. If you look at the next 2 slides, you can see them in more detail. So, you know, for example, nature evolves to survive. It adapts to changing conditions. Nature is locally attuned and responsive. It tries to fit into the current environment. Okay, the next slide, you can see that nature is also, it integrates with development. It is resource efficient in terms of material and energy. It doesn't use more than it needs to. And it uses life-friendly chemistry that supports life processes. Okay? For example, you can see that, you know, people have produced over 300 different types of polymers. You know, a lot of it is used in plastics and synthetic material. But nature works with only 5 polymers, according to Janine Benyus. Only 5 polymers. So you can try to study this and see, you know, what are the 5 polymers. Okay, if we can go to the next slide. Now, how can we start thinking in a biomimicry sort of way when we want to design a solution? The design spiral tells you that there is actually 6 steps you have to take. Define the function, biologize the challenge, discover the model, abstract strategies, emulate the strategies, and evaluate the fitness of the, that means the efficiency of the strategy. Okay, the most important, I feel, are the first two steps. We need to ask the right questions and also decide how nature can help us in the challenge. Okay, if you look, I'll give you some examples of how we can do this. For example, in terms of design questions, a good design question is neither too broad or too narrow. For example, we might ask, okay, how might we end hunger? It's a very big question. It's too broad. And then we might say, okay, how might we design an app to help food pantries get more donations? It's too narrow. So the just right question can be something like, how might we connect institutional, that means food companies that have a lot of food, extra food, to those in need? No, now we have a problem. We have a lot of food being thrown away by all the restaurants and the hotels that can't use them, but there's a lot of people who need food. So how are we going to connect them? So that is the just right question. So for example, we want to ask, how can we make cycling safer? Too broad. But how can we make better lights for cyclists? Is too narrow. It's just focusing on lights. So we can ask, how might we make urban cyclists more visible to drivers at night? So that is a question that's just right. So, in a way, in IB learning, language is very important, right? To science, maths, and everything else. So we need to consider things in terms of language. Okay, and the next slide also is about how you biologize questions. So you've asked the question, but now you need to biologize it. So your design question can be, how might we keep buildings cool in the summer? But the biologized question can be, how does nature regulate temperature in hot climates? Okay, and then the design question can be, how do we reduce storm water? That means, heavy rain, the runoff and flooding in cities. How do we reduce that? So the biologized question is, how does nature manage excess water? Then we can look at nature for examples. The design question also can be, how do we reduce the use of toxic substances in paint? So the biologized question can be, how does nature create color? Nature doesn't use toxic substances. It uses a lot of natural things to create color. Like, for example, the butterfly wings, right? It creates color and iridescence in its own way. Okay, the next slide. So I want to just conclude with, the three roles that nature can play for us again as we look for it for solutions. Nature as a model, right? Nature as a measure, because nature has been around for so long, they know what works, what doesn't work. Nature as an inspiration, as a model, and nature as a mentor. So we need to learn from nature, not just about nature. We also need to stop taking from nature. Instead, we need to see how we fit back into nature. So my last slide, my last concluding thoughts in the next slide is that in the next slide, we need to change. Okay, we really need to change. And we human beings, we always think that everything is endless and limitless. It's not true. Everything else on earth knows that. All the other animals and plants knows that they need to work within limits. And when you're working within limits, like in art, if you're only given a certain amount of things, you can be very creative. So we need to work within limits and try to solve problems that actually, keeps a balance of nature. We need to fit into nature and not keep trying to change it and bulldoze our way through it. And we are mortgaging our future for our present, right? We are using things like a credit card. We're using things that we don't have, and later on we're going to run out of them. And then we need a change of heart, not just technology. So actually, in the end, what happens is we need to have a story. If we are to use our tools, the service of fit, we need to tell ourselves, we need to fit into Earth, not change Earth to fit us. So if we change the story that we tell ourselves, then the tools that we apply will change. So we need to actually change our way of looking at things. So that is the end of my presentation. I want to refer you out. Your teachers will send you some resources you can use that I've picked out. And the next slide will show you, these are some of the resources that you can look at. There's a very good book by Janine Benyus on biomimicry, like I said. And there are all these websites like Ask Nature and Biomimicry 3.8. And there's also a biomimicry toolbox you can use. Actually, they give you all the steps of the design process, like I mentioned earlier. Okay, so I hope that you enjoyed the presentation and you got something good out of it. And I hope you will open your eyes to see nature in a new way. Thank you.
Ms. Li Xian, I think what we would like to know more is how we can change our thinking to come up with ideas from nature that will be functional to humans.
How we can, sorry, can you repeat again, Jonathan?
How can we change our thinking to come up with ideas from nature that will be functional to humans?
Yes, so the thinking that we need to change is, like I mentioned before in the slide with the tree, we need to think about we need to learn in a different way. Instead of just learning about something, it's very one way and it's very old-fashioned. We need to sort of learn from nature. So we need to change the way we look at nature, and we need to sort of try to understand the processes of nature and how they fit in to everything else on earth, to understand what kind of ideas we can draw inspiration from to solve our problems.
Okay, that was a very amazing and indeed a very meaningful and informational talk, Ms. Li Xian.
Thank
Now
you.
I realize there are various innovative examples of products of biomimicry in our daily lives inspired by our nature, which can aid us well in this pandemic crisis. Nature is far more sophisticated and complex than we could ever imagine. In our aim of a sustainable world, we need to search for now and novel solutions, many of them in nature itself. How do you think scientific advancement and sustainable technologies can help us in this current pandemic? Now that we've just realized the vast amount of resources available from nature, I think it's time to move forward. Without further ado, let's welcome our second panelist, Dr. Renat Siu. He is a climate change advisor and a Global Shapers community champion. He will be summarizing our discussion through this topic, ensuring food security in a global pandemic, solving with tech and innovation. Before Dr. Renat starts his session, I would like to encourage everyone to start posting your questions to be answered by our honorable panelists at the end of this session. Ladies and gentlemen, let's all welcome Dr. Renat.
Okay, thank you very much, Jonathan. And thanks, Lishan. That was a really, really fantastic presentation. So just by introduction, I'm actually trained as a climate scientist. And actually over the years, I've been very fascinated by the impacts of our climate and weather patterns on global systems, especially with regards to how climate has an impact on our global food security, which is really, if you think about it, one of those issues that has not really been taught about much in this current situation, like where a lot of us are actually in partial or in full lockdown. One of the key things that we don't tend to pay much attention to is, are we going to have enough food, to feed the entire population in such a crisis? So I thought maybe I would start off by, firstly engaging you guys by asking a poll question. Which country or continent do you think have low global food security? And I think there should be a poll that will be coming up on your screens.
1 minute, yeah?
Yeah. Yeah, it's taking a while to load, but it's good to actually think about, which countries or continents on a global basis, right, has low global food security, because the reality is that if you know which countries have low global food security, then you know that that is your target market, and that is where a lot of innovative solutions need to be in order to solve this food crisis. Yeah, so I can see the question right now. Can everyone see it as well? Yeah, we'll maybe give you guys about 20 seconds to select your answers.
So halfway there.
Okay. Yep, I think all you have to do is just to click on one of the three options that's provided.
All right, poll ending.
Okay.
Sharing
All right.
results.
Oh, okay. So the results, as you can see, shows that 88% of you selected Africa, the continent of Africa, as having a low global food security. 2% say it's Australia and 10% say it's Scandinavia. I would say very good. So let's look at what the answer is. Yep. So if you can look at the map on the screen, you can see that, the areas that are highlighted in red, and this is actually a study that was done by the Food and Agriculture Organization of the UN, because one of the key issues that they were most concerned about is how are countries and different continents actually faring in terms of being able to meet their global food demand. And you can see that Africa, as 88% of you have pointed out rightly, are actually in the low to lowest food security levels. Whereas countries in the Scandinavian countries and Australasia, they belong to the high global food security areas. And it also goes to show here, one of the lessons that we can draw is that developing countries tend to have low food security levels. Why is that so? Maybe some of y'all can type your answers, right, in the chat boxes as well as we go along. And I'll share a little bit more as we proceed with this presentation. Yeah. So what we see is that there is a correlation, right, between countries that have low gross domestic product, lower GDPs, and food security levels. Okay, let's move on to the next slide. Yeah, okay. So if you look at the next slide shows us humanity's, current demand, right, on nature. As it stands, like currently human beings, we use about 1.7 of our Earth's natural resources. And what I mean by that is that, when I talk about natural or ecological resources, you can see that food composition takes up about 26%. So in order to produce food for us to consume and eat, we use up about 26% of our human ecological footprint. So, we are actually using more resources that we can regenerate through things like overfishing, overharvesting of forests, and we're definitely emitting more carbon emissions into the atmosphere. And the graph actually shows you very beautifully, right, that this is sort of a consistent trend across not just the world, but also in countries such as China, Japan, Italy, and Canada. So in order to produce your food, what are some of the natural resources or inputs that are required? We use a lot of water for irrigation, there's a lot of soil that is needed for plants, your crops to grow, and so on and so forth. And if you look at the projections that have been done, I think in the chat group, someone specifically mentioned that, you know, the earth is going to be extremely polluted by the time we reach 2050. That is absolutely true. In fact, scientists have actually done a projection of our current production and consumption patterns. So they've projected that by 2050, we will need to have 2 Earths in order to meet our current demands. And by 2100, like, we will need to have about 4 planets to provide resources to meet human consumption. Is that not crazy? This simply shows, right, how, you know, like, as mankind, we are really not conservative. Like, we don't even think about how much we are actually overusing. We don't think about whether there's going to be enough resources for the next generation, right? So, and so much so that we have actually came up with something that we call Earth Overshoot Day, which happens once every year. And this is really just as a reminder to us, you know, that as human beings, like, we have to be more careful with how much is it that we are consuming. And to a certain extent that we have to change our ways as well. Otherwise, we will reach to a level where a lot of people will continue to face famine, like, right? They wouldn't have enough food in order to put on the table. And so this also brings us back to the current COVID-19 pandemic that we are facing. I'm sure a lot of you have been reading about, you know, a lot of news online about COVID-19. And if you have paid attention, there's also been a lot of news that have surfaced lately around food security. So because of the Movement Control Order, or the MCO, that took place on the 18th of March, what a lot of farmers, agriculture entrepreneurs have found is that they had this issue with logistical transportation. So a lot of crops that, you know, they have harvested were literally stuck. They cannot actually transport it because of the MCO. And this was actually at the beginning of the process. Like, you know, people were not allowed to travel more than 10 kilometers from your vicinity, which was a huge problem. So what happens then, you think, like, with all of the harvested crops? A lot of them actually ended up being disposed, like thrown away. Because with crops, right, especially with vegetables and fresh produce, like, it's very important for you to store it in the right place and only for a limited amount of time. Then after that, they tend to get spoiled very easily, right? So because there was no, they couldn't transport, you know, like, this food supply, rotten, as some of you have pointed out, they tend to become rotten very fast, and you have to actually discard it. So there was a lot of food waste that has happened as a result of the COVID-19 pandemic and the Movement Control Order, right? So in Malaysia, like, I'm sure a lot of you are probably curious, like, what sort of food? Because when you talk about food, right, there's literally so many different categories, correct? There's fruits, there's vegetables, fisheries, livestock, rice. Like, what sort of food is in lack of supply, and what sort of food are we oversupplying in Malaysia? So our scientists, like, here, have developed what we call a self-sufficiency ratio, or SSR. And this study was actually conducted in 2018. What this ratio tells us basically is that if you achieve 100%, it means that your supply currently meets the demand that is needed in Malaysia. If you have any value that is above 100%, then it means that you have a surplus. You can actually export and sell your food in order to gain income. So when we start looking at the breakdown of the self-sufficiency ratio for about 36, right, agriculture products, you can see that actually most of them we have hit above 100%, but there are some crops, you know, things like rice, red meat, so things like beef, mutton, lamb, like are in short supply. Because beef, for example, is only at about 23.9%. So we still actually import a lot of beef produce from different countries. Even things like fresh milk, only sits about 61%. And rice, as you know it, is a staple food among Malaysian families, Asian families. And currently in Malaysia, we can only supply about 70% of that. So we still need to import 30% from our neighboring countries, right? Such as Vietnam, especially. So this is actually quite a scary picture if you think about it, because if the lockdown were to continue, and if we were to continue to close our borders, there will come a time when we won't be able to meet the demands for crucial food products that I've highlighted, especially the ones that are below 100%, right? And I think, Jonathan, you have a question?
Yeah, I'll cut you here for a while on this part, Dr. Renard, as we have a poll posted for our viewers which asked them, what is the percentage of food waste that ends up in our landfill?
Yep, so there should be a poll that pops up. Yeah, so what is the percentage of food waste that ends up in our landfill? Can anyone care to take a guess?
So while everyone is responding, I will note that we as humans really waste a lot, be it in school or at home. I'm pretty sure most of you have already answered the poll. So thank you for your responses. We will see the result now.
Okay, giving 2 more seconds. And we're ending the poll.
Okay, I'm excited to see what you guys have selected. Oh, okay.
Oh, it goes like to show that all of you are actually able to identify the percentage of our food waste. From what Dr. Renard has shared, we have established that our food waste is really high. Dr. Renard, will you be able to share ways on how we can help reduce or solve this issue?
Yeah, sure. But before that, I just wanted to say that it's so amazing to see that, like at least 55% of you have correctly identified that food waste makes up 55% of, our total composition at landfills. And this is actually quite a serious problem, because the reality of the situation that we are facing in Malaysia is that we still have a lot of people who are who are starving, who don't have enough food supply. But at the same time, 55% of our waste consists of food, which means that we are actually throwing away more food, which goes directly into our landfills. So there are a lot of inefficiencies there. So if I may, I just wanted to very quickly touch on this particular slide here that talks about the different components of food waste and where can inefficiencies actually take place. So this whole diagram, the way that you would read it is that it sort of starts on the lower bottom left, right? In terms of production and harvest losses. So from that stage alone, you can see that a lot of our farmers, a lot of our agriculture entrepreneurs, like those who dabble in the agriculture sector, actually face a lot of production loss. So they have a lot of crop yields that are actually damaged because of weather patterns. There's a lot of inefficiencies that are going on in there as well because of things like inadequate storage facilities and techniques. So a lot of our farmers here in Malaysia are what we call smallholder farmers. They own about less than 50 hectares of land, and they are basically involved in their own family-run business that uses a lot of traditional practices. So there's a lot of inefficiencies there, and when they don't have the right technology to store their food products, a lot of them actually become rotten and they tend to go to waste. Then there's also that process of transportation, right? So from storage, you need to transport it to, you know, your wholesalers and retailers. So this is where consumers like yourself would actually go to supermarkets to shop for your food. So what happens when, you know, like within a week, if the vegetables are not sold, right? So your daily produce like tomatoes and all becomes rotten. So you would also throw that away, right? So all of this whole process shows that, you know, there are areas that needs to be improved. And this is where a lot of innovation lies, which goes back to your question, Jonathan. So if I may, I just want to move on to the next slide. Yep.
The controls back to you, Dr.
Yeah, I am trying to move it to the next slide, but I think it's stuck. Yeah, okay. So the next slide is really, I'm going to talk about a little bit about some of the different innovations, right, that has been happening in this space. One of these innovations is what we call vertical farming. Okay, so what vertical farming is that instead of producing food horizontally as what most farmers would plant their crops, what we are doing now is that we are literally stacking them up vertically. And when you actually can go outwards instead of horizontally, what happens now is that you can actually plant your crops in skyscrapers, you can plant your crops in warehouses, and even in shipping containers. So basically, vertical farming holds a lot of promise, right, in addressing, you know, the issues that I was talking about in terms of the ecological footprint. So food crops uses a lot of resources like soil and water, right? But right now, instead of planting them horizontally, you can go vertically. So a lot of people have found that this is actually very efficient, and crop use also tend to increase because it uses less water. So there's a lot of cost savings for our farmers as well, right? So there's a lot of water recycling that goes with it. Okay, next slide. Okay, so the next innovation is what we consider, or what we would call, precision agriculture. So precision agriculture is about doing the right thing in the right place, in the right way, at the right time. So the way precision agriculture works is that we rely on this technology that we call GIS, geospatial information. How geospatial information works is that we will attach sensors across different environmental sites. So if you think about, you know, the agriculture sector in itself, is actually a whole supply chain, right? From the planting and harvesting process to fertilization to actually collecting or harvesting your crops. So all along this value chain, you're able to identify specifically, right, what are your input, like what are the input levels that are needed. So you can plug sensors into soil, for example, to study and obtain data around soil acidity or its alkalinity. You can plug in your sensors to identify the water table levels. And how is this useful to farmers? Basically is that they'll be able to perform agriculture in a more precise manner. They will know specifically how much water is needed in order to achieve optimum yield. They will know specifically how much fertilizers that are needed to apply to their crops in order to optimize or maximize their yield products. So in many ways, this technology has allowed our farmers to become more and more efficient. Yeah. So if we can move on to the next slide. Yeah. So just to very quickly summarize 5 reasons as to why precision agriculture is important. Firstly, it helps in reducing the decline in agriculture productivity because as I've mentioned earlier, farmers are now more efficient, so they can maximize their crops based on the input data, right? Soil acidity, how much water, how much fertilizers that are needed. 2, diminishing and degrading natural resources. So farmers can actually optimize and use natural resources in a more prudent manner. Thirdly, stagnating farm income. So one of the things that you realize is that once uh, farmers or agriculture technologies, a lot of them will actually achieve a plateauing income after a certain period of time, right? Because they're able to meet a certain demand. So they are really unable to optimize and plant other crops. But with precision agriculture, it provides farmers with other opportunities of increasing their income by minimizing the production costs that is involved. So by virtue of just using, lesser water, lesser fertilizers, it leads to cost savings. And also another key reason is the global climatic variation or climate change. So, a lot of us, I'm sure you've heard about, the climate crisis, right? So scientists have warned that we only have about a dozen of years left to cap temperatures by 1.5 degrees. Otherwise, we'll be facing a lot of catastrophic events. So the reality is that climate events actually affect agriculture use. I was in Tanzania a couple of years back, and one of the things that the farmers actually told me a few years back was that they have been seeing a huge, significant decline in their crop production because right now they're not only facing severe droughts, but also extreme floods, which happens in a year, almost a back-to-back scenario. So what climate change has done is that it has led to extreme weather catastrophes, so causing not just severe droughts, but also severe floods, right, which reduces our crop use on a year-by-year basis. And this is a huge problem because our population is increasing at an exponential rate. So what happens when you have an increasing population? You need to have increasing crop use, right, in order to feed your population. And this, unfortunately, isn't happening at a fast enough pace. So a lot of this needs to be factored in, right? So what are some of the different innovations that have come up? I wanted to touch specifically on 2 different initiatives that are currently happening in Malaysia. The first is the Lost Food Project. They are really an organization that helps to close the loop, so to speak. So what they do is that they will collect food that is about to be thrown out by retailers like Tesco and rechannel it to feed underprivileged communities. So those that are homeless, the elderly, disabled communities that are living outdoor, who don't have shelters, who don't have enough food, that's where a lot of the food, instead of throwing it and for it to end up in landfills, they're rechanneling it, right, to these underprivileged communities. The second innovation, as you can see, like through the mobile phone, is what we call Robin Food. So Robin Food is basically a food app that was developed by primary school students, just like some of you in Malaysia through an innovation competition. So the idea that they came up with is that with this food app, they are bringing ecosystem players together. So they're bringing farmers, they're bringing retailers like Tesco, Metro Jaya, they're bringing in NGOs, civil society such as the Lost Food Project, and it's basically helping each other highlight what their needs and wants are. So, for example, if Tesco has a surplus of say 3 cartons of tomatoes that that is about to turn rotten and they want to throw it away, they can actually highlight in the app that they have this food surplus, and someone can actually bid and say, hey, an NGO can bid and say, hey, we actually want this tomatoes because we can use it to feed underprivileged communities. So a lot of such innovation is changing the way that we're doing things, and it is playing a role in helping us to solve the food crisis or food security issue that we are facing. Right? So I think, yep. So I wanted to talk very quickly about two concepts. So before that, I think there is a polling question. I wanted to ask you guys, right, which is the better system in order to minimize food waste? Yep, I think the polling question is just coming up on the screen. Can you all see? Which is the better system to help minimize food waste? Is it the linear economy, recycling economy, or the circular economy? Yep.
And we have about 55% of the vote in, so I'll wait to 80%.
Okay. Yeah, if any of you have come across any of these concepts as well, you can also type them out in the chat group. I'm just reading them as we go along. Okay, so do we have the poll results? Oh, interesting. So 77% says that the recycling economy is the better system to help minimize food waste. 8% says the linear economy, and only 16% says the circular economy. So the answer is actually the circular economy, and I'll explain why in the next slide. Okay, so over here I'm introducing two concepts, right? So the linear economy is what we are currently, or what most Malaysians are currently practicing. So the linear economy is very straightforward. It's take, you make, and then you dispose. So everything that you dispose goes directly into our landfills. And mind you that in Malaysia, like we are almost running out of landfills already, right? And this is a huge problem because we are constantly in this mode where we are, taking from natural resources, we're converting it into products, and then we are disposing of. So the second system on the right is what we call the circular economy. So you make, use, and then you recycle it so that it goes back into a loop or a circular loop. So there is no opportunity for this system to be broken, like where waste can actually come out of it. So yeah, I think I just wanted to show very quickly. I think there's another diagram. If I may just click, yes. So this is how the circular economy works, right? In terms of food security. I think just looking at the chat box, some of you had mentioned, that we do consume a lot. But what happens to our food scrap is that a lot of us in Malaysia, we actually don't compost, right? So that's one of those things that we need to do. We need to compost. We need to mulch our food waste and use that as fertilizers, right? To grow our own crops. And this is an example, one example of how a circular economy works. So everything that you grow, that in your garden, you're able to plug it out, you're able to cook it, you eat it, and then what happens to your food scrape is that you compost it. So this is just one of the many examples that we, can actually learn from and actually adopt. Yeah. So I think my last slide is really about to get you guys thinking about accessibility. So if you think about the situation like say 20 or 30 years back when you don't have any of this mobile apps or technology at all, like Grab Food, Damakan, Food Panda, or food, any sort of food delivery apps. Imagine if you were only using, right, a Nokia mobile phone and you are in a pandemic where you have to stay at home, you can't go out at all. Like what would happen without these food apps? So a lot of this different innovative technology has really helped human beings like us to cope in such a stressful situation. Like if we cannot get food supplies, if we are stuck at home, we can actually order food with just a click of a button. You know, we can make simple payments and food will be delivered to our doorstep, like so literally, like so to speak. So this has already made has already changed the way that we live. It has already changed our lifestyle, and it's also helping to solve food security issues really from an accessibility issue. It's definitely been more convenient, so to speak, right, over time. And what is really interesting about all of these apps is that when you're actually ordering food, when you're actually ordering things like, you know, groceries through this app, they are also collecting data. So another thing, another homework for you is to, you know, maybe Google and find out a little bit more about data analytics. So a lot of these companies are collecting information about your purchase, about your different purchases, right? And they're able to use that for marketing purposes to promote their products. In China, for example, it's so advanced to the point where, you know, if you're constantly buying eggs, like in a consistent manner, and in one particular week when you actually don't purchase anything at all, there will actually be reminders sent to you to remind you to replenish your goods or your supplies at home. This is how advanced, this is how sophisticated it has, gotten to, which is really interesting. So, and I guess with that, I guess I will just end with the last slide to just wrap up to see, you know, given all of this innovation that has happening, what are the solutions that, you know, you can think of in order to help resolve, you know, the food crisis, the food security situation that we are facing in this current pandemic. Thank you.
Thank you, Dr. Renard. It was a very interesting session. I certainly hope all of you enjoyed that presentation as well as I did. I was actually really interested in the Robin Food app where we can be more responsible about our food wastage. I'm not so familiar that there are such agencies or groups that can help us with the disposal of our food waste efficiently. Overall, that was a great back-to-back session. We shall now address the questions from our poll. Please feel free to type in or ask live questions.
Yeah, maybe I can answer some of the live questions that have popped up. So there's one particular question around what is ecological footprint. So I've explained this actually briefly at the start of my slides. An ecological footprint is really, you know, how much natural resources, how much of ecology are we as human beings using? So it includes things like how much water are you using, right, on a day-to-day basis? How much soil are you using, right, to produce food crops? So say water footprint, for example, is a very interesting concept because even the food that you eat actually has a water footprint attached to it. So a lot of people say that we should actually minimize our consumption of beef products because a lot of water is being used, right? I drank by cow, so the water footprint tends to be higher as compared to consuming more vegetables, for example.
Miss Lisa, I think you're on mute. Miss Lisa, you're on mute.
Hi, I've got some questions here as well. I think from Mita of Sumang Jaya campus, You asked whether has any biomimicry failed before. Well, I'm sure biomimicry solutions have failed, as no matter how much humans try, we're not exactly able to do exactly what nature does. We tend to oversimplify nature's design without thinking about the system as a whole. So everything is interconnected. So for example, nature has no waste. You know, we produce a lot of waste, like food waste also. So everything that is left behind by one organism in nature becomes a resource for another. So I think, but failure, I think, shouldn't stop us from trying to find solutions that are inspired by nature. I want to borrow this quote from Thomas Edison. He said, you know, he was asked by a reporter, hey, you failed 1,000 times before you invented the light bulb. So how do you feel about it? And then what he said was, I didn't fail 1,000 times. The light bulb was invented with an invention with 1,000 steps. So every time you try something and you fail, you know, the solution, it helps you learn about something else. So I think that's how we should approach it. And a couple of you, Rajeshwari of KL and Daimin Tony of KL also asked, how can we apply biomimicry to prevent coronavirus and to help us survive the pandemic? So I had some points in my slide, so I hope you can go back and refer to them. Basically, it's actually observing what we need to find and to have during this pandemic period, and looking at nature, asking the right questions to see whether nature can give us some solutions. And Yao Zhu of JB asked whether you can use a flying object such as a drone to water or fertilize crops with the drones like bee does. Well, probably, but it may not be the only way you can solve a problem. You have to ask the right question again. So the right question could be, you know, how do I water my crops efficiently? Then you can look at nature and see how nature manages to irrigate, you know, water its systems and also fertilize its crops efficiently. There are many ways. Under the ground, overhead, you can water, you know, there's many ways, or using animals to assist you. So you can think about by asking the right questions. So I hope I answered some of your questions.
Jonathan, any maybe one question for Dr. Rennet? I think Miss Lee Hsien has answered the question we wanted to ask. How about one question from the group of questions that you have for Dr. Rennet before we summarize the session. And at the same time, panelists, you can also start answering questions on that's coming up there whenever you can.
Yeah, so I have one question from Christina from JB. She asked, what kind of support will the government provide to the farmers as they're having a very hard time? So yeah, I would say that when we think about farmers, right, like they sort of sit on two ends of the spectrum. There are big agricultural companies like your Felda Global Ventures, W Plantations that are multinational conglomerates. And then the other end of the scale, you have smallholder farmers, those that have about, you know, around 50 hectares of farmland. They're a lot smaller in scale. And I think the government is providing quite a number of support. There is a consortium that's providing them with grants and funds to actually explore innovative technology. So one of the innovations that I've mentioned earlier was on precision agriculture. So Ministry of Agriculture is actually supporting such smallholder farmers to transition. They're providing them with, you know, the necessary training that is required. They're providing them with the right support, setting people down to help scale up their business and to help them increase their crop or production use. And this is basically happening actually even before the pandemic, and it's still carrying on as far as I know.
Thank you all for your meaningful questions. I hope our panelists have enlightened and clarified your queries. Your participation is truly appreciated. We have come to the end of this webinar. Please allow me to summarize the session by leaving a key message to our viewers. First, we've learned that nature can help us produce sustainable energy or make more efficient advancements with our current technologies that are already out there through the aid of biomimicry. These solutions to challenges that we are currently facing, be it huge or small, are just all around us. And we need to look around and consider nature as a model, measure, and a mentor. Secondly, as future leaders for our generation, we can help in evaluating and assessing our existing policy impacts on technology dissemination and trade to help the government ensure that their policies can help more development forward. Various ways such as vertical farming and precision agriculture can help us all to improve our food waste and at the same time ensure food security in this global pandemic. Dear participants, this is for you to think and take back as we end this webinar. What are the things around us that we should innovate for human well-being, including nature? And finally, we also had our two honorable panelists who have shared a lot of insights about this topic. I hope you will be able to connect with the current situation and understand the importance of considering various resources inspired by our nature that are already available around us in helping to maintain a sustainable environment. Once again, our warmest thanks to our panelists, Ms. Lee Xian and Dr. Renard for joining us today and all of you who have spent your time with us this afternoon. This is Jonathan McCullough signing off now.
Thank you.
Thank you very much for having us.
All right, thank you, Jonathan. Attendees, so this is the end of our webinar. Though the panelists will be typing some answers for you. I'll leave the webinar open for another 5 minutes. If you have asked some question, you would like to hear the answers from the panelists, and then we will close the webinar officially at 4:15. Yeah. So the panelists will either answer your question live or type an answer and give it to you. The rest of you, if you want to leave, you can leave now. Thank you. Be ready. There's another webinar at 2:30. We will start early tomorrow at 2:15, and I'll start allowing everyone to come in at 2:15 itself, so we can make sure we start on time. Thank you very much.
Question around, oh, it's been removed. Yeah, I mean, but basically the question was around, the fact that we are in a COVID-19 situation, there's a lockdown, right? So how can farmers actually transition out of it by opting for alternative sources of income? So a short and simple answer is absolutely yes. I've seen some farmers that have actually gone into the e-commerce platform. So they're selling, they're procuring products and literally selling them in different markets. So if you follow quite carefully, right, like some of the statistics out there, online shopping has surprisingly actually increased during the lockdown period because a lot of people are actually stuck at home, they get bored, so they tend to go up online, right, to purchase a number of products. So I think there's absolutely a lot of different, alternatives to make an income and make full use of this opportunity. Yeah. And the example that I've given is just one of the many different ways.
Okay, so I think we are to the end of the webinar. Thank you very much for everyone for participating, and I'll see you guys tomorrow as well. All right, take care. Thank you so much, Ms. Lee Xian and Dr. Renard, and for joining us. And
Thank you.
If they have any other questions, I'll come back at you.
No problem. I learned a lot
so
from Dr. Renard.
Oh, I've learned a lot from you too. Yeah, thanks. Yeah.
Bye.
Great questions, everyone.
Yep.
Okay, thank you. Good day. Bye-bye.
Bye.